Trisha, do you want to do the common, if we have one, or the graph? She'll do it, and then she'll pick her friend. Do you want to do the common or the graph? You want to do the graph? Okay. Tell us how to graph this. Use the words left, right, up, down, stay. Left 2. Now what? Up 3. Okay, this one. Do I go left or right? Left 1. Shh. She can do it. Alright, Trisha. 0, -5. How do I get there? How many on the X? So I'm staying, and then I'm going down 5 units. Keep going, Trisha. She can do it. So, Trisha, X value is +1. You go left or right? Good. Right 1 unit. On the f of x or the y-axis, you're going -6. Is that up or down? Keep going, Trisha. X values there too are positive. Do you go left or right? Now what? Up or down? Remember, this is negative. Down. 3, -2. X values are positive. Right 3. Down -2. Right 3, down -2. Alright. Last one, all by yourself. Your X value is 4. Where do you go? Right 4. Picked high schoolers to teach high schoolers. Critical think on your own. So you can graph this. Class, what do you have? Which function family? Quadratic. We're hoping that it has a degree of 2, right? Not hoping, we know. Okay, so that was the graph. Okay, help us get the common something. Leslie L. How do I go from 3 to -2? Minus what? 3 minus 4 gives you -2? Positive or negative? -5. This one? Positive or negative? Here? Here? +1 here? +5. This is our first common difference. Class, is that all the same number? So class, is it linear? Not linear. Alright, let's do the next one. Leslie, can you pick the next student for us? Rogelio? Alright. What goes here? Here. 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 So this is all the same number. Second common difference means it's what, Rogelio? It's not linear. So it basically tells us it's what? Quadratic. Rogelio, pick the next student. Pick the next student. Nathan. How many real zeros does the pink graph have? You are correct. 1, 2. You have 2 reals. Nathan, that means how many imaginaries do you have? 0. So 2 reals. Okay. Let's now go over to the linear. So even though I graphed it over here, we're now going to focus on the linear. That's a linear because it's a line. Nathan, pick the next person. Benito, how many, what's the degree of a linear? Yes. 1. How many reals do you have there? Yep. Can you give me the order pair? Okay, so I'm trying to point out that this is 2, 0. The reason why they normally say something like this, they'll say x is equal to 2. And the reason why they call this a 0 is because your y value is 0. So, why is that important? Well, let's read about Toby. Benito, pick another student to read about Toby. Read about Toby for us.
Function gx has the greater number of row zeros. The graph is 1, 0 at x equals 2. But the table of values has no output value of 0 and therefore no zeros.
Okay, so Toby basically thinks the first part is correct. There is 1 at x equals 2. That's correct. 1. Now look at the table. Toby thinks that the table of values has no output. This is an output. It's your y values. It's the f of x. Toby is saying that because there is no 0 here, right? This is what Toby's thinking, that there's a 0 because your y value is 0, and there's no zeros over here. Then the answer is there's 0 over here. So they're comparing. Toby's saying this is 1 and this is 0. Toby is wrong. Why? If Toby is a he or she. If he graphed the table, he would see 2 reals. Because Toby's basically saying that there are no zeros here. The 0 is actually in between here. Do you see it goes from positive to negative? There is actually a 0 in there and is there. These are basically just decimals. So if Toby graphed it, they would recognize that he is wrong.